Everything you see around you is because of material science. That's a bold saying, but that's somehow true. Every improvement and development in every major is because of the development of material engineering. Like, for example, your phone, your laptop, and your computer, and the camera that I'm recording this video with is because of development of material science, is because of existing of that major. And why is that? In your CPU, a computer engineer had programmed everything. uh, the electrical wires in your phone, in your laptop, in your computer is actually designed by an electrical engineering. The design of the laptop and the design of this phone is designed by a mechanical engineering. Everyone had their own part in creating such a thing. But the material engineer actually designed and created the wire itself. And I don't know, maybe he chose the steel, the glass, the everything that is used in this phone is decided and chosen by a material engineer. Now, you may ask yourself, so how everything is related to a material engineer? Each one of the materials that an airplane wing or a phone or maybe this keyboard that is in front of me, every one of them follows a simple rule, and that is they all have a character. My phone is not the same as my keyboard. For example, I'm going to give you an example with an airplane and a keyboard. We're going to see the difference between these two. For example, when you're designing a keyboard, it's not going to handle a certain amount of air pressure. It's going to be the pressure of 1 atmosphere at most. It's going to be the room pressure. It's not going to be something different. But for an airplane, it's going to fly. It's not an easy thing, and it's going to handle a lot of air pressure and a lot of forces on its wing. Now, if you design and if you use the same material that you use in your laptop, in your computer, in your keyboard, or I don't know, in your pen on an airplane, it's going to crash as soon as you board. And why is that? It's because these materials are designed to be used in a room temperature and a room pressure. It's not going to handle a flying system. Now, that's the character of it. Also, uh, your keyboard, you're going to press on it every day, and in every second, you're going to press on it nearly 2 to 3 times. We have a lot of people all around the world that can type 156 words per minute. It's not words, I guess that's characters. I'm not really sure about that. But you're not going to click on our airplane wing or on our airplane. You're not going to click on it. You're going to board with it. You're going to fly in it. And also, if your keyboard breaks after 10 years, maybe we can say, or 50 years, it's not going to deal a lot of damage. You always can buy another keyboard. The most and the worst thing is that you're doing something important, and because your keyboard broke down, you can't do it anymore. You're not going to get someone injured or anything like that. But for an airplane, if you make a simple mistake, if it breaks down, if it fails, you're going to get a lot of people in trouble. The passengers, the one that actually booked the flight, the airline, everyone, you're going to make them feel some pressure, you're going to injure them, you're going to make something, and you're going to make a mistake that will cost a lot. Now, that's the character of every material in this room. Now, the thing is, as a material engineer, that's your responsibility to check the situation, whether you're going to use it in home, like a keyboard, like a monitor, or you must use it in some place like a jet, a missile, or maybe, I don't know, a car, okay? Everything like that. That's your responsibility to check the character of the material that you're going to use, how it's going to perform under pressure. For example, when you're creating a shield, it must perform very good and it must protect you from, I don't know, if you're making a bulletproof shield, it's going to protect you from bullets. Now, that's how it's going to perform. But when you're creating a car, when you're making a car, when you're designing a car, it's better to say, you must remember that in a car accident, the front side of the car must take all of that force and start to perform an, I don't know, elastic deformation. It's going to deform, okay, just to absorb the pressure that the driver won't get injured, okay? That's how it's going to be performed, and that's how the material is actually going to perform in front of a pressure, a force, or everything like that. So that's performance. That's how we can do it. Now, we have two other parts, that's structure and properties, how the material is going to be and everything like that, that we're going to talk about it in the next videos, more specific. We are going to talk about them more specific. Right now, we just want to tell you what is material engineering. And by the way, we have another part, that's processing. Either of that, we have a part when you decide the material is going to face a lot of pressure, a lot of force, and it's not going to deform, and it must not deform, face a deformation. So you choose that this thing is going to be made out of steel, maybe something like that. It's going to be made out of steel, or made out of iron, or made out of gold, everything like that. That's your idea, or every alloys that you know, or that you create maybe. Now, how you're going to create and how you're going to produce the material. If creating it, you must do a lot of chemical reactions, a lot of, I don't know, things like that, casting, and a lot of process and a lot of ways of creating a material that you must choose. You know, you can make something that is perfect, but that's worth 20 millions of dollars. But your buyers are not going to spend that much money on that. For example, an airplane is not going to worth more than $1 billion. That's a lot of money for an airplane, for just an airplane. So just by creating it, you're wasting a lot of money that no one is going to buy it. We are here to solve a problem. We are not here to make another problem. We are not going to make a problem that it's going to be hard to, I don't know, buy. It's going to be expensive. It's hard to take care of. It must be took care of in some certain situations, like you must cool it down or things like that. We are not going to create new problems. We are trying to solve them. So that's material engineering. Now, in a lot of universities, a lot of famous universities, that you may know them, they all have certain syllabus, and the most part that I know is that in most of the universities all around the world, it's really like mechanical engineering in bachelor's degree. There Exactly the same. Just for material engineering, you're going to read and you're going to learn some crystallographies and some certain things like that. But in mechanical engineering, you're not going to learn that. You're going to focus more on dynamics, statistics, or statics, thermodynamics. In material engineering, you're doing that as well, but not as deep as mechanical engineering, because you're going to learn something that they don't. You have some parts of chemical engineering and some parts of chemistry in your major. Now, if you clicked on this video just to know what is material engineering, if I want to tell to you very simple and in short, I'm going to tell you that it's something that helps people to choose materials, to create stuff, and to find the perfect design and the perfect material and how to create it for a certain industry, like an airplane, a car, a chair, a laptop, and the works, and I can say the jobs that are available for material engineers are so different and they're so big, and you can really work in every industry, as I can say. You can even work in clothes industry, you can work in laptop industry, you can work in, I don't know, air defense, air force, you can work in navy, you can work on cars, you can work on solar panels, even energy engineering, you can read it as your master's. And if I want to tell you that if it is a good major to choose for the ones that clicked on this video to choose their major for their university, if you're asking me that if it is a good major for me, if it's not, I tell you to ask yourself these three simple questions. Am I able to work in a factory? Because most of the jobs for material engineering are based in large industries and large factories, we can say. Number two is that can I face some hard things like fluid mechanics, fluid mechanics, thermodynamics, things like that in university, everything that every engineer reads and learns in university. Am I going to be able to face them, and is it going to be very hard for me? Because I've seen a lot of people quitting it. Although they loved this major, they quitted it. Now, the third question is, am I going to like it? You know, material engineering at first is going to be hard for you because you don't see anything fun in it. You're just learning physics, mathematics, and chemistry. You're not learning anything so, I don't know, abnormal, we can say. Something exciting. You're not going to learn that. You're going to learn things like, as I said, physics and chemistry. Do I love it? So loving it is very important in that part. Now I wish you liked that video. If you liked it, please leave a like, comment, and also subscribe. I will be very enthusiastic to hear about your ideas for the next videos. Thank you so much for watching till this part. I'm Shayan, and bye bye y'all.